Wait, Mar, you could just use logic here. You don't have to use like evidence-based thinking. Just use logic with flat Earth.
Okay, great. You're up next, Chief. Can you give me Earth curve measurements, please?
I would just like to ask why, like, logically, flat Earth makes sense.
Logically, if the Earth was a sphere, it would have curvature. So what I need from you now, logically, is
Yeah.
to have measurements of that curvature. Can you give me the measurements and how they were attained?
I mean, I could look up geodesic data on the Earth
Yeah,
shape,
look it up.
because that
So go
exists.
ahead and do that. Figure it out. See how it all works. See how they get that data, and then get back to us, would you?
Yeah, they gather the data either from satellites or from experiments or other means.
Experiments. How do you get Earth curve
Yeah, like,
measurements from experiments? Experiments have to do with the scientific method. This is not a scientific
yeah,
inquiry. This is
yeah,
geometry.
it is.
Oh, really? It
Yeah,
is. So give me the
geometry.
naturally
Well,
observed phenomena, please.
you can agree that geometry can be used in an
I'm
experiment, right?
sorry. Yeah, and that would be a composition fallacy that you just committed. I want you to go ahead
What
and show
the
me
fuck are
the
you talking
naturally
about?
observed. I know you're already confused because you don't know that you were
No, no,
talking
no.
about
I
logic
literally
a
just
second. You were talking about logic a second ago, and so we're doing this logically, right? So, logically, if the Earth was a sphere, it would have to have curvature. These are all geometric terms. These are not scientific terms. These are geometry terms. So, we're going to be logical. We're going to stick to the topic, geometry. And then now you're going to say that there's an experiment that we can do in geometry. Can you give me the naturally observed phenomena so that we can run it through the scientific method? Please begin.
okay. Now I'm on server muted. Great.
Yep.
Um, yeah. I mean, we can take things like surface tension of water and apply
Mm-hmm.
that on a bigger scale.
Okay, surface tension of water is not the discussion. We're talking about earth curve, not surface tension. So earth curve measurements are what we're looking for. Apparently, you think there's some kind of experiment that we can do. Try again.
Okay. I don't think it's gonna be productive. You're gonna just
It's
Just really
probably not
quickly,
going to be.
just really quickly
Go
with
ahead.
the surface tension thing. Okay, so let's say you have like a rock the size of a tennis ball, and you wet it, and you've got like some surface tension on the outside of the tennis ball. Is that what you mean? And then you're going to scale that up to the size of the globe.
correct. Thank you.
Okay, so what if you just like instead of scaling it up to the size of a globe, let's just scale it up to the size of a beach ball now. Are you going to have a thicker surface tension on a beach ball compared to a tennis ball? No, it's
Yeah.
going to
I
be
think that's
exactly the same, right? Because it's just surface tension. It's going to be the same
yeah.
thickness. Now we could get like a rock like the size of a house, like a ball the size of a house that's made out of rock. Now it's still
Yeah.
just you could wet that and it's still just going to have the same amount of thickness of surface tension on the outside. So
Yeah.
the tennis ball, the beach ball, the house size ball, right? They all have the same thickness of surface tension. At what point, when you're scaling that up, does it start to become a thicker surface tension? Never.
I guess when there's things like gravity involved or a magnetic field that may skew how surface tension works.
Think about your argument there, bro. Just
Because like,
that's just a bad argument. That's
well,
all I'm saying. Just think
no, it's
about it.
not.
Yeah, it
No,
actually is.
the fact that like surface tension can exist and like that water usually
Oh my
falls downward, right? Because gravity,
I made
right?
my point, bro. Continue.
Well, and
Continue
also
with your two.
logically, here's what I actually wanted to get to because like this
Yeah.
is something I always find funny. It's like logically, if the Earth is flat, right?
Okay, let's just start off with the logic. Give us a logical syllogism for the globe. We'll start from there. Just give us a logical
What's a
syllogism.
syllogism? What's a syllogism?
You can look that up on Google.
Oh, I can't. Wait, hold on. Syllogism makes me.
Your little. All right, so like I'm really not interested if I'm just
Oh,
gonna be server muted every
my
time I can't
husband's
finish a
calling.
thought.
Alright, I'm gonna go come.
You're not going to get server muted every time, but if you're going to start the conversation by, let's keep this logical, then let's do that. Let's see if you can prove the globe with some sort of logic. Not going, if the Earth was flat, then, some kind of consequence that you've imagined in your mind. We're talking about logic here. So let's just start with logic. Some kind of syllogism that you can give us relating to, geometry, since that's what we're talking about. In fact, geometry, if you break it down, geo, Earth, metric, or, measure, that's what we're talking about. So some kind of syllogism. Let's keep it real logical.
Okay, so with logic, it's important to note, like when we're looking through a telescope, like when we see celestial.
I'm waiting for you to give me a syllogism or start the conversation. Not looking through a telescope. We're talking about the Earth, not the sky. Maybe we need to back this up, make it really kid friendly. The Earth is the ground, the surface of the Earth. It's not up, it's down. Can you figure this out without any help?
Oh, I can talk now? Great. What I was getting at is that, like, when you think about it, why would only Earth be flat?
Only Earth be flat. So see, you've begged the question. You were coming in here with some kind of logic, I guess, but you've already committed a fallacy. Within your question, are you assuming that the other planets, meaning the other things that should be like the Earth in a solar system based on the geometry of the Earth that is 3959 radius, which you should have measurements of, are you begging the question that all of those other planets are in this begging the question fallacy called a solar system? Please tell me if you are begging the question. I know that you are, but see if you can admit to it.
Holy shit, dude.
Well,
Right.
the issue
I,
is you're committed to a category error here. You have to
No,
establish
no.
that you're in the
I'm
same
also
category. That
lagging,
Earth
so
is
it's
in the
like
same
really.
category as like Jupiter.
yeah, he's got diarrhea of the mouth, so if you talk, he'll instantly talk.
I noticed that off the bat. Jeez.
Yeah.
All right, I'll back this up a little bit. So, like, I try to use logic when coming to conclusions, and if somebody says like the Earth is flat or domed or whatever, my thinking is okay. So physics are non-discriminate. So if the Earth is flat or domed or whatever the theory is, then that means other planets would have to be the same in nature.
Other
Once
planets
again,
again, dude.
So you just
when
did
you
it
say
again.
other planets, you're begging the question. See, you already, in your mind, you think that all that other stuff that you've been told, that you were fed at school, and Bill Nye and Neil deGrasse Tyson and NASA and Discovery and history, you're assuming that all that's true in the first place. You actually have to prove that first instead of saying other planets. It's a category error, just like Yoder said. So, for the Earth to be like these other things, you'd either have to have curvature measurements of them or curvature measurements of the Earth. That would be the logical thing to do.
Well,
Point of
we do.
clarification here, kid, is we don't think flat Earth is inside the vacuum of outer space. We have no reason to conclude that.
Oh my gosh.
Yeah, like we have no reason to
I
conclude that a
just like
satellite orbits a flat Earth, for example.
it's
Doesn't work.
frustrating if I get server muted before I finish a
Sammy,
thought.
look, bro. It's only because you kept over talking. If you can try not to over talk, then we'll try not.
What?
Like we won't server mute. Yeah, you
Literally
like,
not.
you just you're
Like
kind of
just
doing it a
now.
little. You're doing it right now, man.
What? Just completing a thought is interrupting? I
Okay,
didn't
so
know
he
that.
was only muting you while he was talking, so he could talk without you talking over him. As soon as he stopped talking, he would unmute you. Okay, so you shouldn't complain if you wanted to talk while he was talking.
Yeah, I was also interrupted before finishing my thought.
Right,
Okay,
let's try
great.
to have a different type of conversation where no one interrupts then. But look, this is the thing, bro. You have a false idea of what flat Earth is in your head. We're trying to explain that to you. We don't claim that the Earth's a flat disk or a flat planet floating around in the heliocentric version of outer space.
Okay, so do other planets exist? Because there is an implication that they don't.
Planets
no one's-
exist.
Yeah.
Other would kind of assume or imply that the Earth is a planet in the first place. Now, when we talk about planets,
It is.
okay, see, now you've already interrupted me. Great. Doing real well today. Anyways, if you have evidence that the Earth is a planet, then all we need from you is the curvature measurements of the Earth to affirm that.
Yeah, and I would just say refer to geodesic data on that.
Great. Can you show us some? This is your claim. I want you to provide it for us.
Sure. Yeah, just give me a moment.
This happens to be one of my favorite topics, by the way. You're in for a treat.
Can you hear me?
Yeah, man.
Can you? I was here, I think, 2 days ago, and says who provided me arguments that you can't see actually the Eiffel Tower from some place that that is far because of
Yeah.
flat Earth. And I'm interested why is that and how it argument with degrees of our view range.
Yeah, well, SX, I gave you two things to consider, right? One of them was angular size, so you would have to give me the distance at which you're viewing said object, and then we would have to figure out what the angular size of the Eiffel Tower would be, in this case, however far away it's going to be from your location. And then we're going to have to figure out what the angular size would be or is. Number two, if it's in excess of 300 miles, the air is not going to allow you to see that far anyways. So it really doesn't matter. If it's beyond 300 miles, you can just forget about seeing it because the opacity of the air will not allow it.
Well, how the amount of degrees of our view range relates to the farness of our view range?
Right. Well, it would depend on the optic. Okay. For the human eye, it's 0.02 degrees or 0.02 arc seconds. So we need something, greater than that for the naked eye. But if we have a larger optic, something with a larger aperture, we could increase that, but it's not going to be a whole lot. So,
Well,
and then once again, remember the limiting factor once again is the air. So can you give me a specific example of something that we're looking at? And then we can go through all of the different criteria that we would need to go through. Something within range, reasonable range, maybe 10 miles or 20 miles, because the optics and the effects of perspective and everything really break down our ability to see at distance. So can you give me a specific example?
20 miles, for example.
20 miles. Okay, what are we looking at?
Eiffel Tower.
The Eiffel Tower. So 20 miles away from the Eiffel Tower, the actual size of the Eiffel Tower is what? I don't even actually know. How tall is it?
300 meters.
300 meters?
Yeah.
Okay. Okay, 300 meters. So that's the actual size. So now there's probably a formula somewhere that will tell us what the angular size will be after, okay, 20 miles. And then we're also going to have to factor in a few other things. But do you think you could figure out what the angular size of the Eiffel Tower would be at 20 miles?
We can use telescope, but due to air, we can see it actually. That's your second argument. Yeah?
No. If it's within 20 miles, we should be able to see this, right? Now, I'm not saying that the air isn't still pretty thick and hard to see through for 20 miles, but we've seen things at 20, 30 miles. So what I need from you next, since we've gone ahead and eliminated the opacity of the air, we're within range, not close to 250, 300 miles. Let's see if we can get the angular size that the Eiffel Tower would be at 20 miles.
Give me a minute or two to calculate it. Yeah.
Okay. No problem.
Yeah, so I was looking at a few sources, and the radius of the Earth, based on its curvature, is 6,371 kilometers.
Yeah, I understand that. That's the claim. Can you get me the measurement of the curvature? Where did they get that figure from? How did they measure the drop over distance?
I posted the link in the side chat, but they got the data from um, compiling data from previous scientific experiments.
They wouldn't be
Methodology they used
scientific.
was research design and approach.
Yeah, we're
They
interested in the
used
origin, the seed values of the globe. Okay, you know what I mean by the seed values?
seed values. No, I don't know what you mean.
Yeah, so how did they determine the radius in the first instance? If you want to pass this off to just other tests that did it, then we need to hunt those
I mean,
down.
yeah, because I haven't performed these tests myself, so I'm not gonna just
Right.
make a bunch of claims from
Well,
things I don't like. I haven't done myself.
okay, we're not asking you to do that necessarily. We will accept the method by which anybody measured the curvature of the Earth.
Okay. Yeah.
Yeah.
Yeah, verifiably so.
Yeah. So it's I mean, at least according to this website, I'm at lumenwaves.com. I'm not sure the credibility, but um, it says for the summary of key findings, they take into account physical principles. The curvature arises from gravitational forces in the planet's rotation. Measurement methods, techniques such as satellite imagery and geodetic surveys are crucial for calculating curvature, and then visibility phenomena. Curvature influences horizon visibility and can explain certain atmospheric effects like the apparent elevation of distant objects.
Yeah.
Yeah,
So
a lot
all
of
of
that's
that is
not even true.
nonsense. Yeah, that's mostly nonsense and more claims on top of claims. So we need that seed
How is that
value
not?
and how it was attained. Because it's just gibberish. It sounds really sciency, and it sounds like someone did their homework, right? I mean, it sounds all wonderful, but the problem is that we don't actually have any measurements of drop over distance in physical reality. So that's the thing that we're looking for. If the Earth is curving, where is that curve at so that we can measure and verify that this is a ball?
Well, the claim, I guess there's like a straw man claim that people claim that it's a perfect sphere or globe.
Right. So the
Yeah.
difference between the axis around the equator and the axis around the poles, or the measurement around the poles, the difference is 0.3%. So it's damn close to a perfect sphere.
To claim that it's an imperfect sphere requires a measurement.
Yeah,
Also true.
yeah, that's true. I'm trying to see if there's like more actual figures on this website. Um, big formation, equatorial bold.
Well,
Here, I'm gonna.
I calculated degrees, and it's 0.5 of 1 degree. So
0.501 degrees. Great. Okay. So now we have
Can you
that.
do
Now,
arctan rise over run? Never mind.
he was answering a question that I had for him earlier. Okay, so we got 0.5 degrees. Great. Now we have a size. Now, what surface are we looking across in this scenario? Is it the ocean?
yeah.
Okay. Where's the observation point? I'm asking all these things because they all have to be factored into the account. You know, like where are we looking from? What is our observer height? So on and so forth.
What? How far away is the Eiffel Tower from the ocean?
I don't know, but
It's
I'm pretty
inland.
sure it's inland. I was going to say it's quite a ways inland, but he's saying this is over water. So SX or I'm sorry, I forgot your name. How do I say your screen name, man, so I can talk to you?
Jakarta.
Say it again.
You can tell me, call me Jack.
Jack. Okay, Jack. That's going to have to work. Okay, Jack. So is this a real life scenario?
What do you mean? Like near the ocean? What?
Yeah, I mean, are we looking across water, or is there going to be some topography in the way? Is there going to be trees in the way? Is there going to be buildings in the way? Where are we looking from, in which direction, to view the Eiffel Tower from 20 miles away?
I don't know how it will help us to understand the concept. Like, we already understood that we have small amount of degrees of view range, and then we can actually see it's very good, and we just have opacity of air, so we can't use this argument to prove that Earth is circular. Uh,
No, no,
No,
no,
that's
no, no,
gonna
no,
work
no.
out. Look, this is the math. Like for the angular size of the Eiffel Tower to be too small for the human eye to resolve, you would have to be 95 kilometers away from it. Okay, but you could go anywhere in the world and check what the maximum or average visibility rating is, and you're gonna find it's gonna be a lot less than that.
Yeah.
So you're going to be limited, regardless of angular size, you're going to be limited by the visibility of the air from seeing forever. The fact is, we can see so far anyway. Like even if we have a nice clear day, we can see shoreline to shoreline over, say, a 20-mile lake, for example. We could shoot a laser across 40 kilometers and hit a target at just over a meter off the surface. None of this works on a globe. You can't see forever because the air is semi-transparent.
Okay.
It's like
Mhm.
that's the end of the argument for why can't we see forever.
Great. Thank you.
Wait, no, but gravity like bends the light and the
Yeah,
direction.
this is physical obstruction. Physical obstruction because of the particles and the dust and the pollution and the gas and the fog and the mist and all of the stuff that's just in the air in general. It's like you just can't see through it. You can't zoom through it using a telescope. You can't do much about it whatsoever. You might see a
My hot
tiny
take
bit further
is,
with infrared. That's the argument. He's asking us why you can't see the Eiffel Tower from some crazy distance away.
we don't
If the
know
Earth was
whether the Earth is a donut shape, a globe, or
yeah, we're not claiming
flat.
flat's not a shape. Yeah, flat's not a
Okay.
shape. You said two shapes of things and then added flat in. Like smooth, bumpy, rigid. Right? These things they're not shapes. Flat. It's not a. We're not claiming to know the shape of the Earth.
Well, that flat is a form of the Earth could possibly take, right?
No, a flat's not a shape. Flat's kind of like the surface of a square, or it could be the surface of a table that could be any shape, or the
Okay.
surface of the water on top of a lake that could be any shape. That's
Okay,
just
you
a
get my
description
point
of a
though. Like
surface.
the whole debate here is like the shape of the Earth,
No,
which I
that's
don't think
well,
you.
not really. Not really.
No.
Yeah,
Yeah,
flat's
because for it to have a shape, dude, it's going to have like, in this case, if it's at least 3 dimensions, it's going to have volume. But we don't know anything about the space around the shape.
Wait, but it does have volume.
How much
Yeah,
do we
but we don't
really know, like
we don't
about
know
our
anything
reality?
about the space around it that defines the volume. It's called an embedding space.
Yeah, we're not
For all we
even
know,
presenting
there's absolutely no embedding space whatsoever.
exactly. It's not a dimension. It's a surface quality that we're pointing out, that we're measuring.
That's
It's not a
right. So
length or a width or a depth.
yeah, we describe the surface as topologically flat with topographical variation.
Yeah, but like the ocean is the same way because it has different depths, right, and different wave patterns.
Right. It's topographically flat, or topologically flat, but topographically varies with the waves, right? Just like the land. So the topology is flat, but it has topographical features, mountains and valleys, just like the ocean has waves. Those are topography on a greater topology.
Yeah, you'll never witness or measure it to be with respect to anything else but horizontal and vertical. Those are the changes that you'll measure.
Well, yeah, because that's how geometry would function within like a planar type of measuring
Right.
system.
nobody's measured the surface to like change with respect to horizontal and vertical in such a fashion that the surface would be, would correspond with the surface of a sphere. So
Yeah, the
Well, we have
it's
bonkers thing
unfortunate.
is every time it's measured flat. It's never actually measured curved. The curve comes in by assuming that the flat measurement is wrong.
I don't necessarily think, like, be careful not to straw man. I don't necessarily think all scientists are saying that it's wrong because of that fact. But I think, like, we do have limitations on, like, how and why we measure things the way we do. Because we don't have some, like, big machine that can send a scientist with a measuring tape up into space to, like, measure the whole curvature, right?
Yeah, we're not claiming that
So
that's
we
what they
have
need
to
to
make,
do, though. Nobody's saying that. Listen,
well, but we have
they
axial
admit
tilt.
that they are measuring it flat, and they mathematically contort their flat measurements to a model of Earth, a model of a globe Earth.
Yeah, based on satellite data and other measurement
This is before
methods.
satellites. And even today, they're doing it with satellites, ironically enough. So all we're trying to find out is what's the seed value for the radius of the Earth? How did that come to be? We've been looking for that for 10 years. We can't find the
Era-
origin.
Eratosthenes.
Yeah, Eratosthenes, that's a big problem if that's the truth.
Eratosthenes.
Like if
Well,
if
because
that is the truth, that's a huge problem because he didn't actually measure the Earth as a globe either.
no, he didn't. He just took angle of insolation from the sun at different times of the year,
Right. And he
and then
assumed
made,
that Earth had to be topologically curved to accustom parallel rays from a sun.
yeah, based on the position of an object, like I think it was the obelisk that he measured
Yeah.
at
So
different times of the year.
that's right.
And so since
So
there was an
based on what
angle,
rational grounds did he have to assume that the sun rays were parallel from a large object that's at far distance away?
because as they understood it and as we've come to understand it, rays are typically linear in how they are emitted. Of course, they're not perfectly linear. I don't think
Here's the
anything's
problem, the
perfectly linear.
logical problem. He's actually measuring diverging rays, not parallel rays.
What do you mean diverging?
In order to get a difference of angle based off of two different positions, the rays must be diverging. So why would he assume that they're parallel?
I don't know why you would think they're diverging.
Because he's got two different locations, Alexandria and Cyan, and they're measuring two different angles to the sun at the same time. Two different if they were parallel rays, they'd be the same angle.
No, that's presupposing the Earth is like flat and doesn't have an axial tilt for
Oh,
like
so now we're
seasonality.
presupposing it's curved, right? So we're measuring diverging rays, and we're going to assume that the thing that we can't measure, which is whether or not rays are parallel, is curved. We're going to assume then that the Earth is curved, and we don't actually measure the Earth curving either.
Well, we have what's called an axial tilt,
Yeah, that's
right?
also begging the question. That's just watching the sky tilt.
Yeah, so I mean, as far as we know, the Earth revolves around the sun and gives us the seasons that we have,
Well, we
which
don't
is
know
why we
that.
have like the poles.
We're still trying to
Well, we
establish
do.
what
We
we
can
watch is
literally
a
just
motion in the
observe.
sky, dude. You have to think about the reference frames. The observer at this point has no way of differentiating between which is correct, okay, whether the Earth is moving or the sky is moving. The base assumption, right? If somebody were to bash you on the head and you wake up the next morning and crawled out of a cave and looked up at the sky, based off of your lived experience, why would you assume that the ground that you're standing on is moving at night when you look at the stars? I mean, that sounds batshit crazy.
Wait,
Somebody would think you
you're
were hit on the
saying
head.
you're saying like why would I assume if I was like I guess essentially lobotomized or my memory was wiped? Why would
Yeah,
I assume that like the Earth isn't revolving around the sun?
correct. Yeah.
I guess I would be worried about a lot of other things before I worry about that, right? Realistically, but like,
Right.
if I'm to entertain that, I think I would say that I would just look into it and be like, okay, what is this phenomena? Because I'm a curious person. I'm like, what is this phenomena? How do we come to know how the mechanisms are and how it works?
Yeah, so you watch the stars move at night. So you have two options, right? Either I'm moving or the stars are moving. And how do you determine which is happening? Is there anybody that's ever able to measure curvature of the Earth? The answer is no. So why do you assume that the sky is a curving surface?
Well, we've measured the curvature of the Earth, just not sufficient in your standards, I guess.
No, it actually has not been measured. That's at all. That's our contention. It's not just it's not up to our standards. It's actually never been accomplished.
It's never been directly measured, it's inferred through measurement of other things.
Right.
Yeah,
So
yeah, yeah.
people imagine the
But I mean, like,
celestial sphere as a curved surface, and they create a topological equivalence from the curve up in the sky and say, well, as above, so below, invoking magical mumbo jumbo, and say the ground must be curving too. That's exactly how this came to be. They interpreted the sky first as a sphere, which it's not. And then they said, well, if the sky is curved, then just as heaven is, so is the earth must be curving too.
when you say sky, do you mean like outer space?
Yeah, the celestial sphere, which is a concept still taught today in astronomy.
Well, because when we look through a telescope, we're looking at a rounded object, a spheroid.
What? You actually think the night sky is a black ball?
Oh, I think he's talking about like
No,
the
no, no,
objects
no,
in the sky.
celestial
Well, we're
Oh
object,
not
no.
talking about the objects
like
in the
planets.
sky. We're talking about the whole celestial sphere itself, like the
Right.
imaginary celestial sphere.
The idea that the night sky is a rotating black ball with holes poked in it and the light of God shining through. That's what the Greeks envisioned.
Yeah, I don't subscribe to that.
Well, I mean, it's taught conceptually in astronomy to help people understand how to think about the world that they see with their eyes.
That's interesting. Yeah, I'm not an astronomy student, so I
Yeah.
wouldn't have
It's how
much to
people
comment
sail
on
at
that.
night, how
It's
celestial navigation
actually
works.
it's actually where the globe came from.
Yep. I got to step away for a few minutes. Sorry, I couldn't really commit to a deep chain of thought here. I'll be back.
Yeah.
That's
So
fine.
even long before anyone even proposed that the Earth could possibly be like a globe, the ancient cultures envisioned like they basically they needed a way to be able to map out the motion of the stars in the sky. So they imagined like a big imaginary sphere surrounding the entire Earth, and when a star is at a certain point in the sky, they were able to turn that into like a mapping system for the sky to know what the stars are going to be doing, the motion of the stars, the motion of the planets, at what angle they were at in the sky based on your location. Okay, and then people like Pythagoras came along who actually were kind of like mystic cult leaders. That's kind of what Pythagoras was. Don't know if you've looked into the cult of Pythagoras, but they kind of worship numbers and worship shapes. Okay, and he thought that spheres are the most divine shape, the most perfect shape, and because they imagine the sky as being this divine shape, this divine sphere, celestial sphere, then the Earth must also be that as well. Not because they went out and actually did anything empirical. It was like through philosophical reasoning and things like that.
Sure. Yeah,
Yes.
Pythagoras is pretty base. He was like one of the first vegans in history that we know of.
Well, I was watching, he was like a kind of crazy, like mystic cult leader. The story goes. I mean, I don't know about based. Like he
He thought
believed in a lot of
numbers were
crazy
actual
things.
spiritual beings.
Yeah, he thought that like the universe was like a musical instrument, and he thought he like all sorts of crazy things, man. I could go over the list of all the crazy things that and rituals and stuff that these people had. But the thing is, even mainstream
Yeah.
historians, right, like Cambridge mathematical historians, they say that they can't even prove that this guy existed. Okay, they say that there probably was some guy named Pythagoras, but all of the things that are attributed to him is just kind of like nonsense.
Or maybe it's like a myth or a legend
Yeah, he said the Greeks
that was
loved
passed down.
they loved making up these like mystical figures like Eratosthenes and Pythagoras and that kind of thing. It was kind of what they did and attributed things to them.
You know, it'd be fun right now with this with our guest. Have our guest Google Eratosthenes and pull up one of these ink pad pictures of him. One of these
I've
relief
already looked
pictures.
into
Dude,
Eratosthenes.
they draw his head like 3 times the size of a normal cranium.
Oh, really? That's funny. Apparently, his
It's
cult
funny as
members
shit.
thought he could be in two places at the same time, and that he could like talk to animals and things like that. And they legitimately thought that he had one of his thighs was gold. He had a golden
Wait,
thigh.
the Pythagorean cult?
Yeah, yeah,
Yeah, they also had a strict abolition of no consuming beans, which I think is
yeah,
just
yeah,
such an odd thing. Like, why would you
yeah.
prohibit the
Yeah, they thought beings were
consumption of
spiritual
beans?
beings.
If they even thought that if you drop something, like you can't pick something up if it drops on the ground. There are all sorts of crazy stuff. I was looking up, like also another thing, you can't pee into the sunlight. You're facing the sun, you can't pee. Like,
But I
The
Wait, you
golden shower.
can't pick up anything that drops on the ground? What about like fruit that's ripe and falls off a tree?
yeah, I don't know. I don't
This
know. I
whole
don't know
like
the.
thing with Pythagoras' existence, like his entire existence, is just strange to me because like,
Yeah,
why would a vegan not want to eat fruit that falls on the ground, like ripe fruit? Or why would
maybe he
why
just
would a
gets someone else
vegan
to pick it up for him. I don't
yeah
know.
why would a vegan want
Can you
to
eat
avoid
roadkill?
eating beans as well? Like what? Anyway,
I think it's just indicative of the times people were living in, that they were more susceptible to like hysterical facts that weren't really based in like any kind of empirics or anything. It was just more so like,
Yeah,
I guess, an appeal to authority, like, oh yeah, this person said this, and so
Like the
they seem
globe
credible
today.
enough.
Hey, like the globe is today, appeals to
No,
people in
because
the past. Nobody's got direct evidence. It's a myth.
no, that's different because we can use data and logic to make inferences based off of like a bunch of different factors, like with seasonality and axial tilt. And the reason why we
Yeah,
have
well,
seasons is because of axial tilt.
the issue with that though is you're making again inferences. You can't prove anything through inferential logic.
I
May I
mean,
ask?
like, the thing with science is like nothing's really set in stone until we gather more
It
data.
leads to
Kind
circular
of like the
reasoning.
beauty of
So
science.
yeah, okay, that's a concession that you don't know. That's a
Yep.
concession.
I've got
Yeah.
Yep. And
great.
this has to stand up to our real world measurements of a flat Earth, which we've got hundreds and hundreds and hundreds of examples, not just by people in our community, but by people who didn't know that they weren't thinking of Earth as a globe when they were taking long distance observations, saying, wow, I can see mountain range 255 miles away. That's really cool.
I mean, yeah, if it's like 15,000 feet, you're gonna see it like quite a distance away for sure.
And yeah, but you shouldn't be seeing these distances. Like we shouldn't be seeing Baja, New Mexico, the peninsula, from an airplane 760 miles away at 35,000 feet. That that peninsula should be 180,000 feet behind the
Wait,
curvature of the Earth.
Baja, New Mexico? That's not a
Yeah, the Baja
real place.
Peninsula.
Oh, the
it's
Baja
not
Peninsula.
New Mexico.
Yeah, sorry if I
Yeah,
said New
Baja
Mexico.
California. You mean Baja
Yeah,
I was just
California?
Baja
confused. I was like,
California
wait.
Peninsula. Yep, sorry.
Yeah.
Yeah, I mean
Okay,
we've
can I
got
ask a question?
observations of this in infrared from high altitude.
Can I ask you? Okay, I want to ask you about stars. Why can't we see some stars from other place on the Earth, for example? And also, where does Polaris go when it travels south? And what physical blocks it from?
Well, stars are just too far away for us to see from some places. That's all that it is. You know?
Okay, but for example, if we have the same sky, why can't we see some other stars, for example, some places?
They're too far away, man. Listen, like the further away you get from objects in the sky, the lower they appear in your angular field of view. Eventually,
Okay, but
they're going to be obstructed by trees and mountains and valleys and shit in the
and
atmosphere.
the air itself, yeah.
by what? By trees?
Yeah,
You say?
yeah, they'll be blocked by the terrain because they're so low in your angular field of view that they'll be just mere arc minutes of degree above the horizon.
Okay, but
Telescopes allow us to see beyond our natural vanishing point.
Absolutely. And
Our-
infrared telescopes from airplanes allow us to see beyond the curvature of the Earth. Dozens of examples.
wait, you just said beyond the curvature, so when you're in an airplane, you're implying we see a curvature.
No, we're testing to see if there is curvature. We can't find it. You'd think that in infrared, they'd be much more clearly visible, that there'd be a sharper definition of the curving Earth and the sky beyond it. But in infrared, it's flat and you can see beyond where the curvature should be. That's what I'm trying to explain.
May I
Yeah,
ask you
and
also
I
a question?
understand that, but like it. So would you deny like the photo evidence of the curvature of the Earth if they documented that?
Should I automatically accept and believe what people present to me that I can't go out and verify for myself, like pictures from satellites and NASA shit from space? Meanwhile,
No,
what I
yeah,
can do
sure, not
is I can take my
necessarily.
telescope with an infrared filter and go on an airplane and I can debunk the globe. And anybody can. I can give it to you today and you can go take it up and go have fun with it. Now, getting a seat on a NASA rocket to go to the ISS, that's a whole different claim. That's an exceptional claim. And extraordinary claims require extraordinary proof. So, what are we going to do
Wait,
to
so you're
submit
saying
these claims
everybody?
to?
Oh, sorry. Finish. I'm sorry.
I was going to say, what are we going to do to submit these claims to some verifiable provenance? You know, the chain of custody. Well, it's broken.
There is
Well,
also
there's
a problem. May I ask? It's a continue of our previous conversation. Like the star Polaris, for example, travels to south or somewhere when we go in the other side. So actually, it proves that Earth is curvature.
How
Curvature
so?
because
Because it gets too
yes,
far away for you to see, like I was explaining before. Yeah, you go to the southern latitudes or just go south of the northern latitudes and Polaris descends in your field of view.
far.
Boom, 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 boom. And then eventually you can't see it due to particulates in the air. If you're out at the ocean, it's not going to be visible. So here's another
That's not.
interesting factoid I want you to consider. The sun changes its luminosity throughout the day by a factor 23,000 times. The sun is 23,000 times brighter when it's at its high point in the sky compared to when it's just above the horizon. 23,000 times different. How come stars don't do the same thing?
because
Okay,
stars
but
are
I ask you
light
another
years and
question.
light years
Like,
away.
you go
Yeah,
somewhere
so the
in
light's
the,
even weaker than the
you go to the
sun.
right.
Of
Okay,
course, because they're further
may
away
I
in
ask if I
distance.
explain my argument or so?
Yeah, sorry, go for it.
When we go,
I'm gonna
okay,
sit
thank you.
back.
So we go to the right and we perceive as the star that it's actually too far for us from us to actually consider it like moving because we are moving related to it. So when we move to right, it moves left. When we move left, it moves
Follow.
to right. Why is that possible? Because of curvature. The because the
Airplanes do the
gradient,
same thing.
how airplanes related to the
Yeah, you
airplane.
ever watch an airplane fly away?
Yeah,
Yeah, so it doesn't prove anything.
I don't know. Okay.
You understand how perspective convergence works, right? How things converge in the distance, and it will look like things ramp down that are above you and things ramp up that are below you, and they converge into a vanishing point in the distance.
Like in a corridor, when you look down the corridor, the walls look like they're getting closer together. They're not. They just look that way. The ceiling looks like it's going downwards towards the floor. That looks like it's going upwards. They're not. That's just perspective. So when Polaris is above your head, like a light on a ceiling, and you move away, to you, it appears to go downwards towards the midpoint of your view or vanishing point, or in this instance, the horizon, till eventually it merges with the horizon. And then the meteorological conditions and the air are going to stop us seeing any type of light, as akin to when we see the sun. But this is just perspective. You can't see Polaris anymore because it's too far away for you to see, and from your point of view, Polaris has converged with the surface. Good evening, everybody.
Hello,
Welcome,
Jedi.
Jedi.
So if you have a look in the side chat, there's a ton of images just demonstrating perspective convergence on different scales.
To my earlier point, listen, the sun's magnitude changes dramatically. It goes from you can't see it because the atmospheric layers are too dense for the light to push through, it being so intense that it's going to burn your skin. The magnitude changes 23,000 times. Stars don't do this. You got stars that are low on the horizon. They're about the same magnitude as they are when they're directly overhead. The claim is that the atmosphere is blocking the sun, and the rays from the sun are having a hard time pushing through the atmosphere to reach your eyes during a sunset. But the stars seem to have no issue whatsoever. What the hell are they?
Okay, that makes a little more sense. The first time you said it, that wasn't making sense to me. I was imagining that you were laying out that the stars, when they're at your zenith, should be too bright to see or something. This one makes more sense.
Yeah, I said it the other way I got you. Yep. Yeah, it's wild, man.
Okay. So we've said a lot, and I haven't heard the guy or gentleman respond. Is he still here?
If he is, I know he wants to say satellites so badly. He's brought them up a few times, and we can get into that.
That's fine. I'll just kindly ask him to respond to what's been said. We can talk about satellites another time. Who was the gentleman we were speaking to?
I wasn't looking. Hands are tied.
No, that's fine. I'm sure he would have piped up now if he was still here, but he appears to have gone.
He's being polite, a little frustratingly polite, but polite nonetheless. So too bad.
Yeah, he kind of came in swinging, but he changed his tune after a while, which was good.
The other guy, who he told me to call him Jack. He's got like a Koenigsegg in his PFP, and anyways, he's not here anymore. But he's been pretty cool. But I don't know if it's a language barrier problem or whatever. But he almost couldn't grasp, number one, the angular size problem, and also, that air is hard to see through. So he came back with that. I don't know why.
Good assessment.
They really don't teach much about perspective in general at school, which is kind of odd. And the way we see, and I guess we grow up seeing in perspective, but it's like people are just completely desensitized to how much of an impact it has on the way we view things. They don't even think about it. then when we try to explain it to them, they're like, whoa, like, never really thought about it. What's up, Steve? Hope you're doing well too, man.
One of my favorites is the FE core laser test over the frozen lake ISIL in the Netherlands. I mean, geez, like almost 42 kilometers of flatness. Frozen water that didn't freeze with the curvature of the Earth, mind you, because it's flat. Both the laser and the target were 1.5 meters off the surface. And the laser hit the target. They had a super accurate laser aiming device. I mean, people talk like the laser was the star of the show, and yeah, that is expensive, but the device they built for aiming it, the ultra high precision CNC machining that they themselves put forth the effort into constructing, that is the real star of the show. Thank you for posting that, Travis. So Travis posted the link to the PDF to the PowerPoint presentation that this team did. And they did multiple observations and couldn't measure the globe, not with a single one. And to top it off, they're on record for conducting the longest laser ranging test in human history. Perhaps outside of, military applications. We do have another example, actually, from the military. They weren't trying to test for curvature. They were just trying to study the atmosphere. But they shot 149 kilometer beam, actually 3 beams at the same time from one Hawaiian island to another. And the whole point was to study the beam separation that would occur if Earth is a globe and terrestrial refraction was real. And guess what they found out, folks? Those beams did not separate as predicted with terrestrial refraction. So terrestrial refraction is horseshit. The grouping, so they used 3 beams. They used an infrared laser. I think they used actually 2 infrareds. They used deeper infrared and near infrared, and then a green laser. And they shot these, and the deep infrared one was their control. It was flat. But the grouping of the lasers was so tight that they were like, holy crap, the grouping on the target end within the telescope was so tight they couldn't believe that had just happened. How the fuck? 148 kilometers. Amazing. How do I get an infrared laser that does that? It's not like I can go on eBay and pick one up, right? might have to go to the Silk Road on. Oh wait, did they take that down? One of my other favorite non-flat earther conducted globe proofs was by the U.S. Naval Department in conjunction with NATO. So the U.S. Naval Research Lab, NRL, they had a contract with NATO and said, we need you guys to basically send surveyors out to the Chesapeake Bay, military surveyors, right? So we're talking not just like your typical civil engineers. We're talking about people who do high precision surveying work while they're getting shot at. So 2 teams came, a Dutch team and a German team. They came to the Chesapeake Bay outside of Washington, D.C., and they set up infrared cameras. They set up lights on the other side of the Chesapeake Bay. I think it was about 16 kilometers away. And on the recording end, they set up a TV camera basically to watch it, and they were just recording. And they wanted to record the motion of the lights throughout the day and night cycles. They wanted to see how much refraction would shift the lights up and down and scintillate and bleep in and blip out, and as it changes in intensity. They wanted to study that. One of the lights, the lowest light, they purposefully set up as a control to be below the curvature of the Earth. And you can actually look at the document and go to the Earth curve calculator, and you can see that that's exactly what they tried to do. They tried to set this light up behind the curvature of the Earth. And in the least optimal conditions for this to happen, they kept seeing the damn light. They couldn't get that light to disappear behind the freaking curvature of the Earth. The situation was so screwed up for them that they called it cursed, and their final deliverable to the US Navy. Cursed. It was a cursed situation because their control was not acting as a control. They couldn't control for the curvature of the Earth. And this actually led to them creating a new model for what's called the marine layer, that very busy layer of water and air just above the surface of water where the water starts to evaporate. There's just a lot of activity going on. But they had to fudge the temperature data by something like 1 or 2 orders of magnitude difference. They had to move the decimal over like two places for the difference in temperature to make it work. To explain the observation, they had to produce results that they themselves did not actually record in nature. That's called backfitting, and in an academic environment, you'd get tarred and feathered. Good enough for government. Yeah, that was called NATO Sapphire, was the project name. Sapphire, like the stone, Sapphire, Sapphire, the NATO Sapphire trials. We posted this on our home server. I mean, this isn't like classified or anything like that. It's quite open and public. So, very interesting stuff. Or how about the USGS people that went down to Antarctica and recorded seeing mountain ranges from 300 miles? Like from a boat or something. So it's not like they were up 35,000 feet using infrared. In fact, this kind of puts them at the limit for the Rayleigh scattering model of the attenuation of light through the atmosphere. Kind of interesting. So here, we're sitting on mountains and mountains of this stuff. It seems to me that the real professionals, the pros out there in the field doing these actual measurements, the frustrations that they endure and the uncertainty that they have stands in stark contrast to these Discord globers that come in here and they're just totally cocksure that they know everything and that Earth is a globe and it's all been figured out. It's really amazing to see this divergence of mentality between the two groups. So, I mean, forgive me when I sound like I'm holding people like this in contempt when they come in and act like this, because I've read so much higher level academic literature on the subject to know that the real pros have much bigger problems that need to be settled that these guys are completely clueless about when they come in to debate us. There's no humility amongst them. That's the problem. Yeah, it requires humility. If you're going to be open to the idea that you don't understand the Earth the way you thought, you're going to have humility, right? None of us wanted to be flat earthers, folks. Like, we know that it's the most socially derided topic on Earth. Like, it's okay to be a bigot towards flat earthers. You can't be racist to anybody, but you can be a total bigot to flat earthers, no problem. Nobody's going to throw you in jail or shut you up on the internet. One of the fewest groups out there that it's socially acceptable to marginalize. I hate to say. Gesundheit.
Skinnier and
What? So what's next? Maps, satellites and maps, they go hand in hand. You know what's funny is people think that GPS satellites, like, they know where they are in orbit because they're detecting and scanning the Earth as a globe and they're beaming down their coordinates to receivers. It's really kind of funny what the general public thinks GPS is doing. What if I told you that the GPS satellites don't know where they are? They're told where they are by the ground stations send the uplink data to them.
So, what?
Yeah.
The satellite doesn't know where it is. It gets
No, it
told
has
where
to
it
be
is.
told. Yeah,
Yuck.
GPS specifically, I know.
Wow.
Yeah. So you got these ground stations everywhere, and they're optically and by radio tracking these things. And guess what? How do the ground stations know where they are? They assume a Latin long globe coordinate system. So when they do the alt-az tracking of the satellites from horizon to horizon, it's all based off of their point of observation already baked into the globe. So you get all of these guys, and then they send their coordinates in from, they basically transmit to a central system, like somewhere out in Colorado, where it processes all the observations from the ground stations. And then Colorado crunches the numbers and then sends out to all the uplinks where it thinks the satellites should be if Earth is a globe and they're in orbit. And then that packet gets transmitted up to the satellites, and the satellites, okay, thank you. So they get sent like an ephemeris, an almanac, timing data.
So we know where we are because we tell the satellite where it is relative to where we are.
Yeah. Yeah. It's circular, dude. I'm telling you, it's just like these inertial navigation systems in the jumbo jets that we talk about from time to time.
Yep.
So wait, we already know where we are. Wait,
Yeah.
how does that work?
We're on a sphere.
Yeah.
Wink, wink, nudge, nudge. We're on a sphere. So don't be
You know, it's funny.
surprised that the coordinate system works. And you know
This
where
is
you are.
assuming that the tech is even up there to begin with, too.
Well, it doesn't matter, dude. It could be
Right.
hovering 100 foot above the floor or 100,000 foot. It doesn't matter anymore. We tell it where it is.
Have you seen a Loran chart map?
Yeah, I think so, but I can't see it in my head. Long time ago, like 5, 6 years, something like that.
Yeah, I just looked at it again recently. Let me pull one up here for you guys. Do you think they got worldwide GPS coverage?
Yeah, I think this is the one I saw.
8 minutes past the hour.
Yeah.
Right, they're doing that in the 60s, 50s, 40s.
Yeah, of course.
And they're using VHF frequencies. Line of sight. It doesn't go behind mountains and curves very well, if you know what I mean.
Yeah, of course. I think we were
So,
talking to some guy the other day about VHS radio signals. And he said, I think they cut off at about, I think it was either 16 or 26 miles or kilometers. I can't remember. But from about 10 meters.
yeah, tell them to increase his wattage.
Yeah, I think you were here for that conversation as well, actually.
Yeah, I said he was using like a 20-meter wavelength or something. I'm like, okay.
Yeah.
Yeah, like not to discount the job. Very important job, very technical. You can do it pretending you're on a globe all day long. Doesn't matter. Yeah, man. So, is there a way potentially that they could take towers like that Loran map you see, and the towers are sending out timing data, and you put a little doohickey somewhere, some device on the transmitter that alters like the phase, so it gives the appearance that these things are moving potentially, or the
Yeah.
beams originating from a different location potentially.
Yeah.
You know, there was Charlie Wilson, Secretary of Defense during the space race. The guy that they made the movie about, Charlie Wilson's War, starring Tom Hanks. Great movie. Charlie Wilson, that Charlie Wilson, when he first learned of Sputnik, he called it a deep scientific trick. He called it a scientific trick with the radio bleeps and bloops. Yeah, cool trick, Russians. You think that's cool? Watch what we can do.
I fucking agree with you. I fucking agree with you. You're fucking
Thanks.
right. Yeah.
Could GPS be a cheap scientific trick
Keep
too?
going.
Yeah. Well, we know that they're tricking. They're
Bro,
tricking
you're
us
fucking
because
right. Oh, fuck.
NASA, dude. NASA was founded by a psychological
Holy
operations
NASA, holy
program under
fuck.
the president, dude. Did you know that?
This dude is talking the truth.
Dude, I'm cooking.
Yeah.
The entire space program, dude, is a propaganda program. Like openly a propaganda program. The founding documents describe by any means necessary advancing for the public's consumption technological achievements that may or may not exist. Like, what the hell does that mean? Why would technology? Why? Listen, in this document that I'm recalling from memory, there's a section called reconnaissance satellites and a greater section of psychological operations. Why would satellites fall as a subtitle to psychological operations? Oh, a cheap scientific trick indeed, right? How awesome is that? I'm of the opinion that a lot of these people that they don't necessarily know that the earth is flat. A lot of these folks in DOD, at NASA, Pentagon, whatever, they get by just fine believing the earth is a globe. But they also know that what they're doing is sowing seeds of propaganda. To them, what they're doing is they're projecting American dominance.
Yep.
That's their primary mission. And they also think that there's probably some bank of nerds out there that's still trying to figure out how to actually orbit a satellite around the globe, which isn't happening. So I was reading up on the history of the the Dragnet program. I almost called it Skynet. Dragnet. Dragnet was the satellite retrieval program from the Cold War, the early Cold War. So what they were doing, it started off with satelloons, spy balloons. What they were doing is they were flying airplanes, and they were catching the whole satellite system itself. The gondola, which is the metal girders on which the cameras are attached, the cables to the balloon or the parachute. Sometimes they'd pop the balloon, right? And then a parachute would deploy. And then they would catch the entire satellite itself with the parachute using these massive hooks, and they would pull it into the back of a cargo bay of this massive cargo plane. And that's all these pilots would do all day, every day. They'd practice for this. They became very good at it. Well, at some point, they switched over from balloons to self-orbiting satellites because they're competing with Sputnik. And you know what's funny? Their operations remain the same. Their techniques were the same. And you can kind of read the pilots' accounts of this, how they thought it was kind of weird. It was not only the same, but they said it got easier. And what was happening is they went from grabbing the entire satellite to thinking that they're grabbing only the canisters. But what if it's possible that the canisters themselves, the technology got so small that they didn't need these massive steel girders anymore? They're able to shrink the technology down. So they're no longer pulling in these like 6, 7, 8 foot long steel beams into the plane, but we're talking maybe 4 foot wide boxes. Yeah, it's really interesting. Like, why would your retrieval technology and process method, all of that, be the same? I mean, they were told that the canister was from a self-orbiting piece of space junk and had been jettisoned off of it. And that's the part that they couldn't see and could not verify themselves. Maybe it's been balloons the whole time. No, that couldn't be, guys. No. Yes. Imagine being lucky enough to get picked up for that job. I bet that was a lot of fun. I wonder what's harder, like landing an airplane on an aircraft carrier or retrieving one of those. You know how they say that Starlink, the reason why you can see them at night as a bead of lights is not because that they have massive spotlights on them that they're shining down onto Earth, but it's actually a reflection of the sun. I'm gonna have to dig for it, but it's out there. I can tell you that there is an article, a fairly recent one within the last 10 years or so, by a newspaper in Topeka, Kansas. Use the Google newspaper search. Topeka, Kansas newspaper saying you can see Starlink tonight, and it was the winter time at 10:30 p.m. Anyone see the problem with that? Northern latitudes, winter, 10:30 p.m. Space junk that's reflecting the sunlight from, what is it, maybe 300 miles up? How does sunlight reach that if Earth is a globe? Now, what if Earth is flat? Well, then, yeah, maybe it is reflecting sunlight from a flat Earth orbit of some kind. Why? Well, because the sun is just way over there from that high up. Maybe on a flat Earth, if you were to go up like 300 miles, you could see the sun again at 10:30 at night from Topeka, Kansas during the winter. Ever think of that? Man, I wonder if I saved it. Now I'm really curious. I know I saved it, but my Dropbox folder is just a hot mess. That love drama guy keeps getting the mute and the boot, doesn't he? I
Yoder,
think that's Rich. Rich Evans.
Rich is rolling around or what? I mean, hey, Yoder, I sent you a DM. Something random. I wasn't looking for anything. I was just saw that video that's playing on the TV, and then, while watching it, they're using a huge magnet that is used for some pharmaceutical procedure, some medical procedure that they do in the heart. They use two magnets side to side, and then in the middle will be the patient, and they'll be moving like a tool inside of the patient's body with the magnets. And at 15 minutes, he mentions how they use the magnets to create a new North Pole on the tape.
Oh yeah.
Basically,
Yeah, right. You
yeah.
can use the harmonic fields of magnets to create synthetic poles. I don't know what they're actually called, but yeah, I know what you mean.
Yeah. Kind of cool. I've never seen that they were able to guide something with magnets inside someone's body, but just a little Easter egg that they mentioned they can do that. Yeah. Interesting, huh?
Yeah. We live in a big magnetic field for the audience listening, duh, right? But did you know that Earth has 3 poles? It's the funniest thing, right? Nobody in the public talks about it, but it's not like they're hiding it either. There is what's claimed to be a South Pole in Antarctica that does not move. And then a North Pole that kind of wanders a bit. And the third pole is somewhere out in the southern Indian Ocean, and it moves a lot.
So when I picture that, right, and they put the two magnets, this machine that has 2 huge magnets, and is doing this movement above the table where the patient is laying, so above the flat table, creating this movement of the pole. However, they guide the magnets. So That's kind of like I picture it in
I love it.
in a probably in a more complicated way, like a creative level. I don't know. So interesting. Yeah.
Immediately, what comes to mind.
Field, the magnetic north moves, so I can, like the imagery of the, let's say, the silhouette that we're observing. In my opinion, it could be like structural, like actually like a structure, and that structure is kind of like wobbling. Because we see the sky doing this wobble, right? They say it's the earth doing the wobble, but it kind of looks like the sky is doing that little wobble, and the kind of like that's having an effect on the ground, and the North Pole or the poles are having that wobble of the sky. That's why they kind of like wobble on the ground, or the expression of it on the ground. What we detect on the ground with tools, right? And we label it magnetic north or
Yeah.
magnetic south. Yep.
Yeah, the Earth is like a gigantic hard drive, and it records the magnetic interactions on it. So geologists have gone to crazy places like this. The Mexican hat dance, awesome. Geologists have gone in some austere environments in like Patagonia and the peninsula of Antarctica, whatever you call that, the Antarctic Peninsula, I guess, right? And they claim to have retrieved rocks from down there where the magnetic alignment within them is just a bit more than 90 degrees off of where it should be right now. And in order for that to happen, they say that extended, like there's a long period of time where, for whatever reason, that rock was picking up or recording the field in this way, even though the field is currently oriented that way. Right. And so it's not just like anomalous either. Like an entire region of the Earth would display this feature. So it's not like maybe the boulder tumbled down from a mountain or something and got disoriented. It's like, no, everything was uniformly aligned in that direction. And then you look into catastrophism, you look into what people are saying now about crustal displacement of the globe, and like the globe's crust is going to become decoupled from the mantle and it's going to rotate 90 degrees. No. What if instead the Earth is stationary like we know it is? It's the freaking sky that rotates. I mean, wouldn't it be weird to see Polaris in the east? Wouldn't it be weird to see the sunrise from the south? I mean, there's some geological data that suggests that used to be the case.
From the
And some
creator's
people think it's
design and our
happening again.
perspective, it's pretty obvious what you said, that this is obviously that the sky is moving. But I wouldn't be surprised if the Earth itself is kind of like one of those gears of the whole construct that the creator can, move as well, like another gear, the whole machine. Still, yeah, it's pretty obvious that the sky is doing all of that movement. See a lot of people in here. What's been going on? I just joined.
No, I've been talking to myself for the last like 40 minutes or something.
No way.
Yeah, way, dude. Like I've been babbling longer than I typically do, and I'm like cooking dinner and eating at the same time.
That's what I just finished cooking the dinner, and now I'm gonna sit down.
Dude, I just had the most delicious. I'm still eating it. I have fillets. I have cod fillets that I pan cooked in a nice garlic lemon herb sauce concoction.
Sounds delicious. I like cod.
A nice buttery, greasy kind of fish. It's, I don't know, just so satisfying. But anyway.
We mix it. I mean, people make it like a salad with it, like some onions, tomatoes, lime. They also add like a bunch of avocado, like slices of it or squares of avocado. They mix it all together. Tomato, onions, avocado, lime, and like that. Yeah. delicious. I'm having some lamb shoulders, avocados, and some, how do you say, plantains, but the yellow ones that are sweet instead of the other ones, the green ones. Sweet
Yeah,
plantains.
bananas.
Bananas?
Yeah, plantains. No bananas, plantains. Different.
Man, what a world, dude. So if there is going to be a new North Pole, if there is going to be some catastrophic event, like the Globers are saying, but it actually happens on a flat Earth, the new celestial North Pole is going to be somewhere east of Madagascar, which puts
The new celestial North Pole. Oh.
Huh?
You said the new celestial, the celestial North Pole will move to Madagascar.
Yeah, like you go east of Madagascar a ways and you look up, and that's where Polaris is going to be seen directly overhead. So somewhere in the Indian Ocean. You know, and that kind of coincides with where, interestingly enough, where the Indian Ocean magnetic dipole is moving. The third magnetic pole of Earth is moving in that direction right now. Like the magnetic poles have been moving so fast that the National Geospatial Intelligence Agency and NOAA have been updating like the world magnetic model at faster increments of years than they ever have before.
So there's more action than usual, or there's more activity of recording the action.
More movement of the magnetic fields than they've ever seen.
Wow, that's
They've got records going back like 200 years.
Does it have to do with more equipment tracking the stuff, or they're saying there's a change of activity and we are recording that increment in activity of these changes?
No, they're saying it's moving, man. Like you could set up a compass on your desk and mark where north is, and then come back like 10 years later and your needle moved. That is what they say is happening. And it gets crazier. The intensity of the field is weakening, they say.
Does that have any effects on the environment? You said the field is weakening.
Yeah, the idea is if the field is weakening, then it means the ceiling that protects us from the rays of the sun is getting closer to the earth. And if it weakens too much and the sun launches out a belch, even on a flat earth, it could fry a portion of earth. The grand barbecue. The grand solar barbecue.
I think that actually has a name in these groups. I'm probably gonna look it up in my DMs. Yo, you. What's up, you? Yo, you? Okay. So you're interrupted for all that? There's a term for the sun, like you describe it like sun burning. I mean, if the sun gets more intense and we have less protection from it, it could burn stuff, huh? Melt things.
Yeah, it could melt buildings and cities.
People can reflect the sun out of a window or something and fry an egg without fire.
You see that guy on YouTube? He ripped out like some sort of screen out of it, like an old TV or something, and he turned it into this gigantic lens on a swivel, right? And now he just focuses the sun's light onto this surface and just puts like rocks and metals and coins, all sorts of different things to see what will melt from the sun's light. He makes obsidian out of it and everything. It's crazy.
I knew it. That reminds me. I used to work with a guy. He actually he was a geologist and actually spent two tours in Antarctica. Yeah, like what? Yeah, but he was goofy, man, and he was old. He's probably not alive anymore. But he was describing and showed me when I went to his house how he built a freaking a mazer out of a microwave and his radio equipment. Just took the big fat Taurus magnet out of a microwave. I think he disassembled the TV. There's some like TV parts in there too, like you're describing, and radio gear. And he's like, "Yeah, baby, this is a mazer." I'm like, "What the hell?" Yeah, he's probably long past. Actually, he was about 20 years ago. He was in his late 60s. You know what a mazer is? It's like a
That's
laser,
what I'm
but
wondering.
instead,
What's that?
yeah, yeah, it's like a. So it's not a laser; it's a mazer. It's basically using instead of light frequency, radio frequency. Yeah, much bigger. You take a pencil thin beam, you make a directional high gain antenna, basically like ultra high gain antenna, and you can focus a lot. It's probably I probably shouldn't talk about it. But they do use these in atomic clocks. So yeah, it's got some, some peaceful uses.
I think you read my mind when you were saying making a laser with that stuff, like a radio laser or whatever. I'm like,
Yeah.
sounds like people can mess stuff up with that.
Yeah.
Sounds like the wrong that with the wrong mindset that would be a bad idea.
Yeah, it just you know how much like the old tube TVs have charged up inside?
Yeah, I
It's
remember people saying
dangerous.
no, it was dangerous. Yeah.
Well, what if you use that to power what this is? Just saying. Discharge all of that in an instant in a fine beam. You could see through walls. And you're not scanning.
I think I've seen videos of people taking the I think it's called a magnetron microwave.
Yep, that's exactly
And
it.
you point it out like a light bulb that isn't connected to anything and it lights up distance.
Right. So when Tito was talking about like a parabolic mirror that focuses light into a beam, the magnetron is like a parabolic mirror for radio.
Dangerous. Very cool.
Yeah. Yeah. So guys, I mean, if we wake up in a post-apocalyptic world someday, you might need to build one of these to survive. Man. Yeah, he was a guy that actually first told me all those years ago about the magnetic field lines registering like 90 degrees off on all the rocks. Right? And then I forget about this, right? And then I start researching flat Earth, and it's all the flat earthers talking about this shit. I'm like, oh, hey, I saw this once. I saw this episode on TV. Right? I'm like pulling old memories, shaking the cobwebs off, blowing the dust off. I'm like, holy crap, I heard about this. If I keep talking, I might get in trouble. Let's get this back on track, guys. Let's talk about flat Earth some more. But it seems so boring. We were talking about death rays and shit. Yeah, I know. I'm happy to see that Jay Tolan has produced now 2 videos in like the last month after going silent for a year and being relatively silent for more than 2. It'd be great if he would hang out here with us. I know some of his videos are somewhat controversial, like he thinks there might be vegetables on the moon. I'm willing to look past that, honestly. For his contributions alone, he should be commended. And maybe there is fucking vegetables on the moon. I don't fucking know.
You've got me interested in the whole year you've been. I want to wait until the winter solstice, start measuring and see if there is an extra day on the 4th. I want to try it out.
Oh man, do it. So maybe we could get together a group or something. That'd be fun to try as a group and see if it works. But I I did use I used agentic AI, and it dug up some meteorological records that I actually put my own eyeballs on. It showed that this was the case. You know, and when I first heard about this on a podcast by Antonio Subarats, God rest his soul, seriously. The guest that he had on to talk about this also produced the receipts and was showing the data live on the podcast.
Yeah, I'm going to give it a go. I'm going to record it each year, see what happens. I'll send my results in years.
And so I've got a request to talk about the Marianas Trench and the waters below the waters. Yeah, I mean there are dense layers. There are different density layers of water going deep. I mean, we've seen those pools, and sometimes you don't have to go as far as the Marianas Trench to do it. There are videos of scuba divers. Like, I don't know, somewhere around the Caribbean, I want to say, maybe the north part of South America, where there are these dense brine layers of ocean water that's cloudy, and you can swim into them and disappear. But maybe you're asking more about the subterranean oceans that people say they've discovered, that there's multiple times more water underneath the ocean floor in another ocean below that. And there may be communicating vessels, that is to say, there may be tunnels, and the water may be flowing in and out of the tunnels. Is it possible, folks? Crazy thought. The amphidromic points that we associate with tidal nodes, could those be holes deep under the ocean where the sub-ocean is communicating force wave feedback with the above ocean? I don't know. It's fun to speculate. Nobody freaking knows, so may as well speculate, right?
That's actually close to how I picture it. I mean, you said it pretty well. The water's below pushing or moving. There's some flow, and that movement causing those tides above it. There's
There might
something
be
to
some
it.
geological pressure difference change going on. Who knows? Yeah. Wouldn't it be crazy if there was some exotic substructure to the Earth like this that was actually pumping, and that pumping is actually producing the day and night cycles? Yeah, folks, I know it's not Speculation Sunday, but if you're going to speculate, at least speculate on something cool that people haven't talked about before. Sorry, was that a boring thought for you?
Well, talking about the magnet, I'm creating a new North Pole. I mean, that's gotta have some effects on, you know, the ground. I mean, whatever is here on the surface, and maybe below it, because the effect of the magnets are not just on the surface, is it?
I don't think so.
So the undulation, a movement of the sky. I mean, just trying to picture it as simple as they showed it in the video that I sent you. But I know it's not as simple as that. I don't think so. It might be.
I mean, there's some flat earthers who think that there's a large part of our world that was actually technologically developed over aeons. So basically, if you go out far enough and dig deep enough, you're going to find potentially like the very architecture and structure of our world was created by man. Cool thought.
What do you mean by that? The architecture and structure?
What if the magnetic fields were artificially created by man, and we're living inside a gigantic Helmholtz coil?
I don't know what to think of that, to be honest with you.
Yeah, me neither.
Why would somebody create a magnetic field around their Earth?
The field was from Cthulhu. I don't know. The speculation gets wild. I know there's some Gnostic heresies out there, and I'm just going to put this out there. I'm not saying I subscribe to this in the very least, suggesting that we are still inside Noah's Ark.
What? What do you mean?
Exactly that.
You mean the boat?
Yeah, was it a boat or was it a metaphorical boat?
Okay.
I get it. This is the kind of fun speculation that people come visit us for, and we don't do enough of it, but usually when we do it as a community, we suck at it. I think a lot of people suck at it because they're just repeating some top level flirt shit they heard from terrible apps that they downloaded in the iTunes store.
You know, I heard one speculation here one day from a newcomer that I hadn't heard of before. Right? Said that, yeah, okay, yeah, the entire structure is probably immovable, right, not moving. But who says that the land, right, the continents, isn't like moving, like turning, right, within the structure, right, and you know, giving the appearance of celestial motion, right? Because it's just a one feature within within a singular solid structure that isn't moving, right? And I was like, that's an interesting thought, you know. You know, like because it's thinking outside of you know, of the box kind of thing. Yeah.
Yeah.
It's just moving so at a rate which makes the stars appear to move, but we don't, it's just like the Globers say about the globe, it's just beyond our perception.
Yeah, what if the creator didn't pay his rent and he had to move, so he took the earth with it? And he moved to the new apartment, to his
What if,
new lab.
like, what if the flat Earth is kind of on a turning table that's off center? In the perceived rising and setting of the stars is just due to the hyperbolic vision that we have, where objects of immense size and vast distances appear to take on a different geometry. And this is actually proven in some of the literature. We can quote from Lüneburg and Glinsky. I've got some papers on this. It's really interesting how the eyeball works, how perception interplays with the eye. I've heard Indio bring this up, right? Like if you watch an airplane, like super high up, like 40,000, 50,000 feet at its highest ceiling, and it's leaving a contrail. I'm not talking about chemtrails, guys. And it's going to the horizon. It looks like a straight line and like it's going down, like it's going to smash into the earth. It doesn't look like it's going out like streetlights do. And there's actually some biological evidence for why this is the case. Inside your eye is actually a hyperbolic structure called the energetic pseudosphere. And this determines how images are projected at various angles that's off center from the retina or from the fovea in the back. I was in the middle of a thought, didn't mean to cut anyone off who wanted to get in, who thought that I was done talking. So please.
That's a new term for me. Energetic pseudosphere?
Yeah, the energetic pseudosphere.
Bro, I've been looking into the eye for a while. Why did I got into this? The energetic pseudosphere?
Yeah, you know how some flat earthers have speculated that the celestial sphere might be a pseudosphere? Well, the eyeball just happens to have a pseudosphere structure in it that determines how images might be processed.
Yeah,
Crazy,
that's interesting.
dude.
Yeah.
Let me go find this. I'm going to post it. I mean, I posted this in our home server. I'm just going to go dig up the stuff that I posted on that. Shit, maybe I didn't. I posted in mod chat.
So, T-Dub, could you repeat that speculation?
Oh, it was just the notion that the land masses are moving through the ocean, I guess. I guess the ocean wouldn't be moving, or it could be too. But like, so there's a zone, a layer that's actually rotating inside what the realm, right? Giving the appearance of celestial motion, but not the entire thing that's happening within itself is moving. Like the whole entire, it's just like the environment that's providing, that process is not moving itself. It's stationary, but there's this section within the system that is turning, and that would be the land masses. I guess the water would have to as well, because you can go out, park yourself on the boat on the ocean and watch stars move too. So yeah, that, I don't know. it was just an idea that someone had put forward, and I was like, oh yeah, I guess, I hadn't thought about it like that. Doesn't mean that the earth is moving, it means, well, the soil is, right? The soil's moving, but not the entire system.
See what you're saying. Probably explain the tides a bit better.
Yeah, you could borrow from Neil deGrasse there a little bit. Right, the land's moving in and out of bulging water, right? Or torrential water. dynamic, movement of waves, and swells.
I see what you're saying. Yeah.
Yep, receipts posted, guys. The perception, human perception, hyperbolic vision, and the pseudosphere. There you go.
Thanks for that.
Oh yeah.
You're welcome. And I'm going to read it for the listening audience, since we have people that are on YouTube, people that are driving, people that can't see, and they might be curious. So, so for image context, I posted a cutaway of the human eye showing where the pseudosphere structure is. And I wrote up an article on it, and then I posted an article and an excerpt from that article. So this reads, the concept of the energetic pseudosphere, see below image, and its tilt, because it's tilted off an optical axis, as modeled in non-Euclidean hyperbolic geometry of the human eye, relates to visual perception of the night sky. In this framework, the eye's macular region is approximated as a pseudospherical surface with negative curvature, influencing overall visual processing, including stereoscopy, depth perception, and the integration of visual fields. This geometry contributes to the perception of the sky as a finite dome or vault rather than an infinite Euclidean plane, which can make distant luminaries, such as stars, the moon, or planets, appear to behave counterintuitively in terms of perspective and parallax. For instance, in hyperbolic visual space models like Lüneburg's theory, infinity is rendered as a bounded dome, aligning with how humans experience the celestial sphere. Straight lines in physical space, such as the vapor trails or star paths, may be perceived as curved due to the eye's scanning and integration of successive visual fields, exacerbated by optical effects like coma and the tilt of the retinal structures relative to the optical axis. This non-Euclidean curvature affects perspective by causing parallel lines to diverge or converge differently than expected in flat geometry. And it impacts parallax by altering binocular disparity cues for vast distances, making stellar parallax, the apparent shift of nearby stars against distant ones, seem negligible or absent in casual observation, even though it's measurable astronomically. While the specific 6.3 degree tilt relative to the optical axis, this is the energetic pseudosphere, isn't directly tied to the night sky examples in the literature, it contributes to the overall hyperbolic mapping of the retina, which underlies these perceptual phenomena. Studies on visual illusions and spatial metrics further support that the non-Euclidean representations often feel more realistic for large-scale scenes like the night sky compared to Euclidean ones. These are the scenes that we see in our daily lives up close. This explains observations like the moon illusion, where the moon appears larger near the horizon, or the domed appearance of the starry sky, which deviates from naive Euclidean expectations of linear perspective and depth. Yep. So enjoy the article that I posted on this. The biology of the eye, the interaction of the eye, and the physics of light and optics and human perception psychologically. It's all amazing. It's all tied together. What we see may not be how we envision reality to be. And this pertains to the night sky. These objects of vast, immense distances, unexplained, we cannot triangulate them flat or globe, their heights. We have no idea what they are, how they manifest. And with the crazy hyperbolic shape of our eyeballs, it just adds even more chaos. And yes, you can create cameras that don't have the same shape of your eyeballs, and you can view these things in that way too. People have done that, right? So, in fact, the celestial sphere that we commonly understand is a model for how we envision the night sky, going back to antiquity. You can throw that out the window because modern cameras don't interpret it necessarily that way. there are star trackers that don't treat the night sky as a gigantic revolving vault or dome like a sphere, like a hamster ball, but treat it as an observer-dependent box where the observer moves and the rays from these objects come from an undetermined distance. So what's happening is every individual cannot triangulate, cannot point to and intersect consistently where these stars are in this star tracker system. It's called Gaia, which happens to be just like reality is, right? If you were to observe a sunset and you see the reflection of the sun rippling across the surface of the ocean from the horizon up to your feet, an observer that's 10 feet away from you is not going to see the reflection of the sun off the surface of the water where you see it. He's going to see a reflection of the sunlight to his feet, and you're not going to see that reflection that he sees. Pretty weird, right?
Yeah, that's the tricky part. When
Yeah.
it's almost like it was designed to make 99 or 90 something% of the people just quit looking into it because people are just gonna, most people are just gonna drop it. Like, how does that work? Who cares? I mean,
These
even this
uncomfortable thoughts people avoid, man. They don't want to. They don't want to engage. Who cares?